Okay, welcome to your final review of all of the algebra questions you should be able to do by Wednesday's final exam. So every question style I could come up with is represented here. Question number 7, I probably am not going to ask you something like that, but I'm going to go through it anyway just to show you. But the rest of them you should be able to do. So we'll start one at a time. Your first question, there are two ways to solve it. Now remember, the most important thing about math is whatever you do to one side, if you do to the other, it'll keep it equal. So because of experience, I know if I multiply both sides by 4, I know since this says a quarter of 4, if I multiply it by 4, I isolate x. So all I'll have to do is multiply this side by 4 as well, and I'll get the answer of 12 over 5. That's if I multiply both sides by 4. And since that's an improper fraction, on your test you need to be able to change it back to mixed, and your answer would be x equals 2 2/5. But there are some people, and I know you exist because I created you, that would rather multiply both sides by a common multiple of the denominators. They've gotten into a habit that whenever they see an equation that contains fractions, they will look at the denominators and find the first multiple they share. And 4 and 5 are your denominators. So 20, if I multiply this side by 20 and multiply this side by 20, I should maintain equality. But the great news is, when I do that and cross-reduce, I'll end up with 5x equals 12, right? By simply multiplying both sides by the common multiple and, most importantly, cross-reducing, you create an equation that does not have fractions, and therefore, when you solve it, you get the same answer, but a completely different pathway. Just out of curiosity, how many of you multiplied both sides by 4? Okay, totally, that's what I would have done. How many multiplied both sides by 20? Nobody, okay. Second question, much easier because it's just decimals, not fractions. Question number 2 just gives us a decimal coefficient. It's as easy as this question. This question and the question in question are the exact same style. You just have a coefficient, in which case if you divide both sides by that coefficient, you isolate your variable. Whatever you do to one side, do to the other. Don't grab a calculator. You have $1.75 divided into quarters. There are 4 quarters in a dollar. There's 7 quarters in $1.75. So therefore, your answer should be -7. If you don't believe me, take your calculator. $1.75 divided into piles of quarters. It's 7 piles, I think. There we go. Easy peasy lemon squeeze. Question number 3. Almost as easy, except this time the two different parts to it is our variable is on our right side, which is not typical, and our coefficients and constants are decimals, which is your grade 9 learning outcome. This is your constant, this is your coefficient. Just like if you were thinking of an easier question like, oh, for God's sakes, grapes of wrath, where am I? Right here. There we go. Oh, for the love of gravy. Forget it. I'm going to add 1.8 to both sides because I know I want to get rid of my constant before my coefficient. Don't grab a calculator. You can do this in your head, -2.2. And then once you have this, you're going to divide both sides by your coefficient, which is -3.5. And we have something very atypical happen here. Oh, shoot. When I take 2.2 and divide it by 3.5, I get a very long decimal. Now, on my calculator, I can actually see where it starts to repeat. So the 2.8, let's see if I can do it with a little thing here. Hang on. Let's see if I can get this here. There. So there to there. Am I wrong in saying that repeats to infinity? So 0.6, 2.85714, 2.85714, 2.85714, 2.85714, 2.85714, 3. That 3 is the 2 that has been rounded up because the next digit, it was a 2, but the next digit would have been an 8 and therefore rounded up. But that's the repeating. So technically, your answer is x is equal to 0.6. If you wanted to put the exact answer, 2.85714, 2.85714. 0.714 with a bar above it. That is the exact answer. Or you can say x is approximately equal to 0.63. Either answer is the correct answer, and on your test, if you do either one of those, you will have the correct answer. This one here requires a fairly substantial decimal place in your calculator, but probably most of you just rounded it and therefore used the approximately equal sign. Question number 4. What question is this? 4. 5. How many of you subtracted 3/4 on both sides? The easiest way when you have fractions is to determine what the first multiple is, and since 8 is the first multiple both sides share, I'm going to take this side and multiply it by 8, and take this side and multiply it by 8. Now technically I didn't need brackets on that left side because it's just one term. But 8 multiplied by negative 1/2. 8 multiplied by, since it's a binomial, 3/4, and 8 multiplied by negative x over 8. Those are all of the things I need to do to solve this. And you have to cross-reduce. So Jordan, what will this cross-reduce to? 4 and 1 give me negative 4 for my side. When I reduce this, Bree, what will that multiply out by? 8 times 3/4 is what? What's 8 times 3/4? Say this number. Those are going to be a gift for Sunny. I'm going to wrap them up. 6 is correct. Yep. And then when you cross-reduce this, you're just going to get negative x. So if you multiply both sides by 8, you end up with a significantly easier question. Your constant 6, I'm going to subtract it from both sides. Negative 10 equals negative x. I am not done. Who can remind me what my last step is when I have a negative 1 coefficient? How? Divide both sides by negative 1. That's right. X equals a positive 10. All right, for the next question, however, we have distributive property. Now, if both sides, I'm going to give you an easier one first. I'll just give you the typical one like this. If you're using division first to get one group of this number has to be divisible by this number. So the question you need to ask, is this number divisible by this number? If you know it is or isn't, if you know it is, then you can use division first if you want. But if you don't know, I don't advise you do it. I just advise you to use distributive property. Because when you have distributive property, there's two methods you could use: distributive property expansion or dividing by the multiplier. In this case, you're going to get a very simple, I think I could do that in my head, 2.75. Yes, it is. Negative 2, or plus 2.75 equals 0.75. Is that right? Tell me I did that right. I'm amazing. Then you're going to treat it like a normal question. Constant, coefficient, get rid of your constant first. Once you have your, down to this, divide both sides by your coefficient. And 2 divided by 2.5. $2 divided into 2.5 should be 1.2. Is that right? If I got that right, I am locked in. Oh, no, it's not 0.8. Shoot. X equals positive 0.8. Question number 6 is a really simple question, even though it looks complex. If you have mixed fractions, what I advise you to do is just rewrite the entire question as an improper fraction. My personal opinion is it makes your life that much easier. Because now we have two choices. We can do this, or we can do this. How many multiply both sides by 10? Okay, how many multiply both sides by 2? Both methods work. I'm going to do both. So if I take this equation and multiply both sides by 2, multiplying this side by 2 and multiplying this side by 2, cross-reduce, what do I end up with? Just x plus 1. If I take half of x plus 1 and double it, I have x plus 1. If I take 9/5 and I multiply it by 2, I get 18/5. Now, probably from experience, it's best to change this right now, especially because of the next step. So 18/5 is really 3 3/5. I know I'm going to need it right now because what am I going to do to isolate x? What's my last step? What's my last step? -1 from both sides. That's easy. So if I asked you this question, that's tricky, isn't it? What's 18/5 take away 1? Well, it's 13/5, but you don't know that because you have to really understand your numbers to get that. But if I asked you, what is 3 3/5 take away 1? It's pretty easy to do it that way. But anyway, it's up to you. Either way works. That's your answer. If you multiplied both sides by 10, because that's the common multiple of the denominators, multiply by 10, multiply by 10. Take a note right here. When I multiply the numerators, Caden, what's required when I multiply 5 by the x plus 1? When I simplify that, I have to multiply the 5, which is the numerator, times the x plus 1. I need to use distributive property. That's right. Which is going to give me 5x plus 5. Over here, when I cross reduce, I get 18. So significantly easier looking than here is this equation, 5x plus 5 equals 18. Subtract 5 from both sides, you get 5x equals 13. Divide both sides by 5. And you get x equals 13/5 or 2 3/5, which is the exact same answer we got over here. Now this is your kind of your tricky question. There's two ways to do it. If I gave you this question, what are your two options for the easier version? Abby, give me one option for this question, the easier one that's not here. What would you do? You can divide both sides by 2 or? Right. So you can use division first or you can use distributive property. You divide both sides by 2 or you could expand using that. If we use division first here, what are we going to divide both sides by? This is question 7. I'm going to divide by 1/3, correct? That should still work, correct? Right? Dividing by 1/3, that will work, correct? But I have to divide this side by 1/3 as well. So if I use division first, dividing both sides by 1/3 will give me this, right here. Over here, 3/1 multiplied by the reciprocal. What's 3 divided by 1/3? Quick, anybody? 0.33. No, it's 9. Right, key flip change. Right? Now, if you did this, you can subtract 1/4 from both sides. What's 9 take away 1/4? What's 9 take away 1/4? 8 3/4, correct? Oh, good God. Then I'm going to divide by 2. Divide by 2. 35 multiplied by the reciprocal of 2 would be 35/8, which is your answer, which is 4 3/8. That's a lot of work. Able to get that? Did I make a mistake? Did I make a mistake? What's that? All right, my smart hooligans just corrected me. Okay, I can be wrong. Listen, I'm okay to be wrong. Here I made a mistake. I'm supposed to multiply by 2. X equals, so we'll go back here, that's 32/35 over 4 multiplied by 2 over 1, which is 70 over 4, which is equal to, how many 70s? There's 10, there's 20, no there's not 20, there's 17. That's 17, that's 40 plus 28, that's 68. The answer is 17 and a half. My mistake. Did I make a mistake again? Okay, question number 8. Variables on both sides. Remember, I want to just draw it real quick. 2x's minus 4. 5x's plus 7. First thing you want to do is get rid of this and get rid of this by removing it from both sides. What that looks like numerically is a negative 2x on both sides. 0 pair, negative 4 equals 3x plus 7. Subtract 7 from both sides. That's if you subtract the constant from both sides. And finally, divide both sides by 3. Now, because it didn't have fractions, you could actually keep it a decimal. Negative 3 decimal 6 repeating. And your last question. Bree, tell me the easiest way to do the last question. Yes, you do. Tell me, quick. Tell me, real quick. Multiply both sides by what number? No. 6 is the number. Why is 6 the number? It's a common multiple of the denominators. Now watch. Cross reduce. 3, 1. Cross reduce. 2, 1. 3. Multiply this numerator would be 3. Multiply this numerator, which is going to be 9x plus 3. Over here, 2 multiplied by each of these terms. 10x minus 4. We good on that? Next step. Get rid of the 9x because you have variables on both sides. 3 equals x minus 4. Therefore, x equals 7. When you add 4 to both sides, x equals